Hey, Mr. Harridan here. Now we're going to go over some other types of calculations you can do here. Going to go over some percent composition problems here. Okay. Percent composition, we're going to do the infamous part over whole times 100 to find these. These are going to be your elements here. Masses. This is going to be your molar mass down here when I do that. Okay. Key part here, you have to write the right formula first when you do these. Find the total molar mass, then you can just do your part over whole thing. Okay. What is the complete percent composition of potassium carbonate? Remember, potassium is K plus 1, carbonate is CO3, 2 minus. So the formula we're really doing here is K2CO3. Since there are no numbers in this problem, the first thing you need to do is find the molar mass. So there's a K, a C, and an O. There's a 2, there's a 1, and there's a 3. Potassium is 39.10. Carbon is 12.01. Oxygen is 16.00. This should be 78.20. This should be 12.01. This should be 48.00. You add those all together, and I have no idea what it is because I never wrote it down. Awesome job, Mr. Harridan. That's what makes you a champion. Actually, Mr. Harridan, you're already a legend. You don't need to be worried about being a champion. You're already a champion. You're a legend. Yeah, at least I realize what mistakes I'm making here. So this is 138.21 G/mol. This is what I would call the whole. This is a part. This is a part. This is a part. Okay? So then, why did I not leave myself enough room to do this? I'm going to do percent K. 78.20 over 138.21 times 100. And I end up with 56.58% K. I always round percents to hundredths. That's just me. I expect you to do the same. Percent carbon. You do 12.01 over 138.21 part carbon over whole times 100. And you end up with 8.69% carbon. Then you do percent oxygen here, which is 48.00 over 138.21 times 100 equals 34.73% oxygen and percent carbon there. And these percents should add up to 100 if you did it right. If you get 99.99, you're okay. If you get 100.01, you're okay. It's close enough. Okay? Oh my goodness. We're back to barium chlorate hexahydrate again. Oh boy. Barium chlorate hexahydrate. The infamous BaClO3 2 6 waters. Okay, let's find the molar mass of this thing again. Barium, chlorine, oxygen. Now, since I'm looking for the percent oxygen in this one, I'm going to separate out my hydrogens and my oxygens. Actually, I'll just do it this way. 1 barium, 2 chlorines. Put it on the screen, Mr. Harridan, so you can see what you're doing here. Oxygens, we're going to do 12, because there's 6 here and 6 there. And then hydrogens, we're going to do 12. So this is 12 times 1.01, which is 12.12. 12 times 16.00, which is 192.00. 2 times 35.45, 70.90, and 137.33, which is 137.33. 137.33 plus 70.90 plus 192.00 plus 12.12 adds up to that. Oh yeah, I remember that molar mass. It's 412.35. Gee, balls. Down with the gangsters. Now, since we're doing percent oxygen on this one here, this is the part I'm going to use, and this is the whole. I'm not going to find them all because I didn't ask for all of them, so why would I find all of them? So we're going to do percent O here, which is going to be 192 grams of oxygen over 412.35 grams of oxygen, grams total, times 100. And you end up with a percentage of 46.60% oxygen. Easily done. Muy fácil. Okay, you guys are champions. The legend is out.